Hi everyone, my name is Nivedita Murthy, and I'm here to talk about DevSecOps, the good, bad, and the ugly. About me first, I'm a senior security consultant at Synopsys, based out of Boston, Massachusetts. I started in security after I got inspired by movies and sitcoms, and I started with security operations where I worked on network, incident, and application security, moved on to SaaS, pen test, SCR, vulnerability triaging, risk assessments, and finally into DevSecOps. I've been working in this field for around 3 years in DevSecOps, actually. And then while I'm not working, I like to travel, read books, and take photos as and when I can. So what am I going to talk about today? All about DevSecOps. I would like to first introduce you to the whole world of DevSecOps and then explain the need, move on to the good, bad, and the ugly parts of it. As you can see by the name, it's an amalgamation of development activities, operation support, and security checks. It is a cultural mindset altogether. It requires coordination and sync between teams involved in the SDLC process. This synergy is obviously helped due to automation. DevSecOps is not a quick fix or a temporary solution. It is the long-term implementation you play to gain long-term goals in ensuring an organization is able to achieve and maintain secure SDLC practices. It requires the development teams to follow a standard SDLC process, such as waterfall or agile, and ensure that they don't break the process. One is easily able to detect this as well. And while not going too much into details, developers ensure they maintain versions of their code and follow a peer review process before the code is moved to various environments. Segregation of duties is a must to avoid one person from one team or one team to have full control on how things are updated in the code or environment. This means a separate team is responsible for development, a different team is for testing, and a different team for deployment, etc. Operations team is also is responsible in supporting the operating environment, the entire development process where it runs, which includes maintaining and updating the operating environment, defining and implementing a deployment process while logging every detail of the same. Security team is responsible in identifying any vulnerabilities being introduced through this process and ensuring it doesn't reach production. If it does reach production, there's a clear trail of why it could have moved over there. DevSecOps or even DevOps insist on traceability so that it's easier to identify what change resulted in a problem or a security incident or an incident itself. While changes in the code is traditionally what starts the process, DevSecOps starts way before that, and it requires other activities to complement this process. Design reviews and post-production monitoring, for example. DevSecOps is also a lot of moving parts, like the different wheels that run behind a clock to ensure that it reflects accurate time. DevSecOps, as mentioned earlier, is development, security, and operations. Each stage of SDLC requires some kind of security review, but these reviews don't end at the end of the SDLC. Security checks are done before and even after that. Because DevSecOps is not a process, but a cultural mindset that needs to be adopted and encouraged. Hence, every activity related to development, even if it's not actual development, must work hand in hand with security and operations. You start off with training developers in writing secure code. You surround development teams with secure development standards and frameworks to work on, and have security champions supporting teams in their secure development efforts. Champions are chosen because they are part of the development teams and have a keen interest in security. This way, they can evangelize about security within the teams. What follows are several security reviews, along with the path starting with risk analysis, architectural reviews, threat modeling, which come into picture, and then during design and planning stage. This is followed by source code reviews, and then either manually or using various IDE plugins that can help you run a quick scan, and then SAST, SCA, DAST, IAST scans that run during coding and testing phase. These can be repeated at every stage of development, such as at build, test, and release stage as applicable. Then we have penetration testing done on post-production, but not on the production environment, to identify any vulnerabilities found using any vulnerabilities that were not found using the previous methods. You also continuously monitor your production environment for threats using tools such as RASP, and inviting external researchers to test your critical applications by offering a bug bounty program. All of these offers various methods of testing your application for resilience against security. DevSecOps insists the integration of all of these along with functional testing methodologies to test both your software's resilience against bugs as well as security. We talked a lot about development activities, but DevSecOps is not just limited to that. The third part of this whole thing that we often ignore is ops or operations. All operational activities need to be reviewed. One can now build up infrastructure as code. This makes it easier to stand up or stand down environments easily and consistently. We now have various options available to run our software app or application. The best way to observe and watch an application work and identify security issues in its truest form is while it is running in its environment, which means you will also need to run checks and identify for security issues within the environment itself. Some of these issues could directly impact your application. Hence, it is important to secure your environment in which the application is hosted in. All right, so does this mean that this can be done with just one tool? Absolutely not. While there are several tools out there that offer mixed services, there's no one-stop shop tool that does everything for you. You have tools that help you run the whole process and tools dedicated to identifying vulnerabilities using different methodologies. One thing that I observed is that now a lot of companies that used to exclusively offer one tool now offer something else within this, like with a different methodology, like an SAST with SCA or SCA with SAST. And then another thing that I have also observed now is that a lot of SCM companies that offer SCM tools have also included SAST and SCA capabilities in their environment. You have tools from open source as well as proprietary. Note that no one tool fits all the environments, and in some cases, no one tool fits the company itself. In my opinion, it's not how it should be, the latter part, but it is very rare, but possible. I think in such cases, organizations should run a bunch of POCs and see what fits the environment best. I think there will be a difference of opinion among different different implementers and security folks in general, which I would definitely like to talk about. DevSecOps tools are not just restricted to doing just scans, but also to do with others such as reporting, defect tracking, management, environment building tools, etc. Also, please know that it is not restricted to just the tools that you're seeing on your screen right now. Even a simple thing such as a script written either in Shell or PowerShell or even Python offer various capabilities. There's a larger world out there, and choose wisely. So why does everyone, talk about this? I don't know about you guys, you all out here, but when I see the whole DevSecOps implementation happening, come alive and watch as the changes trigger jobs, which in turn trigger scans, which in turn triggers generates metrics and reports issues as applicable and make or break the deployment. It is really magical for me. Watching a lot of work being done in minutes or sometimes even seconds is mind-blowing. DevSecOps definitely helps team scales up big time. We all know in general, security teams have always dealt with a resource crunch, but that doesn't stop bad actors from taking advantage of a vulnerability that's available out there. With more and more applications moving away from a monolithic structure to a more multifaceted, multi-pronged, agile method, security teams need tools to catch up and buck up and make sure they have control over what's being released in production. Plus, there are only 24 hours in a day, minus the 8 hours, sleeping, which is important. DevSecOps lets you crunch a lot of work in a really short time, speeding things up, cutting down on delays and scalability are the biggest advantages of DevSecOps. With global teams across different time zones, organizations are increasingly seeing the need for processes and frameworks that helps get teams together and help and reduce dependence and helping, while achieving the goals through the same process. What I found in several organizations is that they have different teams working as the independent verticals or businesses having their own independent silos. How does one work in such a fragmented environment? How does one manage to get some consistency while still allowing for leeway into each team or silo which they require because the process demands it? How do you get teams working on a goal they all agree upon, but unable to change the entire development process? Can we do a gradual change instead of a full-blown change? DevSecOps is able to accommodate all of these requirements and maybe more, no matter at what stage the organization is in terms of security or how fragmented or centralized the organization is. DevSecOps lets you initiate and implement security activities and lets you adapt to different functional teams. You may have often heard this phrase, security is not one person's responsibility, it is everyone's responsibility. DevSecOps makes everyone participate in the process and practices this very same rule. Developers, app managers, ops teams, security teams, reviewers, testers are all involved in this process. One of the biggest wins of DevSecOps is traceability. Since processes are interconnected and automated, it is extremely easy to determine what change resulted in what issue or problem. In terms of IT error tickets, this would be which change ticket resulted in a problem ticket or an incident ticket. This level of traceability also makes it easier for people to make people accountable and responsible for their changes. With additional monitoring, it induces developers to be more careful while writing code and writing secure code, actually, which prevents the pipeline from breaking. In the current project that I'm working, an email gets sent out, once the entire to the entire development team once the job completes. It notifies the team whether if the application has met the security requirements or not, and in both cases, it lists down the name of the developer who checked in the changes at what time and what were the changes out there. Now you don't want to know that you don't want the entire world to know how bad you're writing the code, right? Yeah, you saw this right. Time and again, I have seen client expectations out there that I first thought, what were you thinking when you said this? But then the next moment in my mind, it starts turning out, how can I make this possible? Yes, DevSecOps can make a lot of those far-fetched expectations into reality, but it requires a lot of time and effort and a lot of other factors as well to work it out before it actually happens. Unlike other methods, a full DevSecOps implementation takes time and a lot of patience is required. So what are the good things about DevSecOps? The first and obvious answer is automation. Automatically triggered builds, scans, deployments, evaluations, approvals. Automation works for all. Now, since these tasks are automated, security team can focus on their important activities rather than just the operations part of it all. As an example, with 700 apps in scope and counting, it would have been very difficult for a security team of, let's say, 4 to be able to monitor regular releases if these were all manually done. The time taken to do this would have been really long. However, with automation, the team can now balance out the work a bit. Recently, the team received a request to onboard and scan 30 microservices, 2 days, right? Just 2 days before production. With the automation piece, we were able to complete this in 2 hours. Not just that, right? Like 30 new microservices onboarded on 2 tools. We ran the scans, evaluated it, and triaged the scan results, all done in 2 hours. That is the power of automation. Earlier, I mentioned global teams being the norm, and with work from home, we also have other challenges as well as distance team members. DevSecOps helps to create a framework which reduces the dependencies to do tasks and activities. A lot of organizations have teams spread across different time zones, as is Asia, UK, EMEA. In my client's case, it is like while the security team is in US, Majority of the developers are in India and China. The security team does not have the budget nor the bandwidth to support all time zones. DevSecOps helps them to support developers in India by monitoring code being checked in late EST or early morning EST. We are also able to create portals through which developers could run on-demand scans in some cases for on-prem tools. Another big advantage that I really liked about this standardization is that instead of it being a chaotic world out there, it is more standardized, which makes it way more easier to wade through the steps in this process. With standardization, it is easier to scale up the process and make updates and additions as applicable. Anything more? Of course, there is. Acceleration, speeding things up, agility, another pillar of DevSecOps. Fast-paced worlds need fast-paced solutions. DevSecOps offers that. With manual steps and dependency cut out, the whole process, start to finish, gets done faster and earlier. In the earlier example, all of those 30 microservices got done in 2 hours. That is the speed that teams are looking for. With less than a week available for the whole SDLC cycle, security gets very less time to run its activities. With a lot of security team tools today have improved in terms of time taken to scan and provide enhanced capabilities to customize the scan and select checks to run so as to cut down on the scan time, this way optimizing it. Speed is extremely important in DevSecOps. Traceability, with all things connected, one can actually connect a change request to a problem ticket or an incident ticket or even a security incident. An example would be where an organization had to deal with a breach due to a vulnerability found. And turns out this was actually introduced as part of the process, and it went through your normal DevSecOps. SaaS tools were able to find it, and it was reported, and then an exception was granted. The respective application team had taken responsibility for it because they didn't consider it as critical, or they would be fixing it in the next release. So this way they were able to trace it down. That this is something that the organization didn't, or rather the application team did not realize the impact of this, the risk that they accepted. Now, so next is scalability. One of the reasons why DevSecOps is so popular is that it lets security teams scale up really high with limited bandwidth. Just again, like the same example, 4 members can, in a team are now still able to provide support to 700 plus applications that would have not been possible without the current automation piece in place. At other clients that I work for, they were able to drive remediation efforts for around 600 plus applications and change their blocker, requirement from critical to high to mediums as well. Flexibility. Let's say the organization wants to transition from one tool to another. Now think of that to be done for 1,000 plus applications. The whole scene looks like a nightmare, but with DevSecOps, it is actually possible to do this in a much more phased manner and easy, less stressful way than what it would have been without that. So if it's so good, is there anything bad about it? Well, we haven't reached utopia yet in DevSecOps. Because there are so many pieces involved, it is not necessary it will work as one big happy group out there. Every organization has to deal with prioritizing their activities, and DevSecOps may not be on everyone's priority list, even though they do understand the advantages of it. In some cases, it could be that the DevOps team itself doesn't want to introduce security into the process because it does require a lot of coordination, a lot of dependencies as such. The other reason would be that not everyone is the same. You have apps, and then you have apps that use legacy tools or framework. Time and again, you will find teams that are supporting legacy apps because there have been no plan to transition them yet. Example, while majority of your application would be using Visual Studio 2019, there would be a few apps out there that would be using VS 2012 or even 2010 for that matter. Or for that matter, SharePoint apps, using the old framework. even now we do find some security tools that may not integrate that easily with the other tools, with the whole process out here. You have to create a layer of abstraction so as to make it use of it in SecOps process. For example, Burp until recently did not have a CI plugin. Hence, it wasn't easy to integrate a Burp scan into the automated process. Then we have those legacy applications, apps that organizations continue to use. It's critical to functionality, but it was written ages ago, and hence there can be no changes done on it, or no one actually wants the changes in it. Assigning resources to automate such apps does not make sense. Or in some cases, it is partially part of the DevSecOps process, but like you may get the app being evaluated using the standard process, but since there are no changes happening, it does not make sense to add some webhooks or monitoring for any changes, because that will never happen. But these same features will utilize the SCM or CI server resources as well. While evaluating an automated process, you need to check what is the ROI of getting it done. You need to take baby steps with DevSecOps. It is not a quick fix at all. It requires patience and tenacity to implement it all. Any DevSecOps implementation takes a minimum of a year for sure. Anything less than that is incomplete. DevSecOps involves a lot of planning designing before you actually start with the solution. You need to first identify the gaps in your current process, followed by then to see what tools would be required and how do they support the process you are implementing. Then comes coordinating with different teams to get their buy-in, and then followed by all the teams implementing the required changes. This does not happen overnight. If you were to make changes onto your process, it affects all involved in the process and all applications following the process. I heard someone say we will go and make this big bang change with this one. If all of your applications are being scanned using a common set of libraries, unless you put in specific conditions, any changes in these libraries will impact all of your apps. Getting a new application added to the process may take long depending on certain factors. But for example, I find that .NET applications usually take a lot more time to be onboarded, because you need to ensure that they build correctly. I would say 30% of my time actually is spent in resolving issues coming out of .NET builds. Because Visual Studio tends to hide a lot of build errors and provides dependencies on runtime, which is not done by MS Build. Countless of times I've encountered scenarios where the app team has built the application using Visual Studio and checked in, but since our automated process uses MS Build command line, it breaks due to a variety of reasons: incorrect directory structure, missing dependencies, incorrect dependencies, etc. And then the CI tool itself is not up to mark at times. A lot of organizations start their CI process using Jenkins, and because, well, it's free and open source and pretty popular as well. But you have other CI tools in the market, for example, GitLab, TeamCity, etc. But if you're using Jenkins, you are probably aware of the fact it is buggy like a lot. I've lost a lot of time, and have been stressed out with the number of issues that keep on coming up with Jenkins. In fact, one time I lost one entire day, or actually 2 of that, because of I had to revert an upgrade. It's pretty recent. But that doesn't mean it's not useful. Yes, it still has its pros and cons of it. I haven't used TeamCity and GitLab as much, so I cannot comment on the bugs or the cons of those tools as of today. Finally, the worst part. Developers themselves can be deviant little tricksters, though it is a very tiny fraction of it. There have been times when I have had to escalate it to the manager. The other thing is that tools do not have the level of maturity to do everything that is needed. Every tool has its limitation and what it can and cannot do, especially in an automated process, though that area is declining. To give you an example, Jenkins cannot probably allow conditional parameterization. Maybe there are some plugins which offer some workarounds, but not that actual requirement. And finally, the biggest headache any security team that has to deal with is false positives. I have this one app that keeps on throwing up 360 plus critical every time we scan it, but I have no idea why. I've yet to determine that. But I don't. If you have any good ideas out there on how to get rid of false positives, I would definitely like to hear that out. Yes, and yes, we still need DevSecOps. It really makes work way more simple and streamlined. I hope this whole presentation actually helps you understand the nitty-grittiness of DevSecOps. There's still a lot more to talk about in terms of OPSEC, which is part of the DevSecOps, but then that will be a whole new topic itself. You can connect with me on LinkedIn and Twitter, trying to use it a bit more, but let me know if you have any questions. Thank you.